So my name is Clay Moseley, and I work with the Department of Public Utilities. I'm the Deputy Utility Manager for Gas, Water, Sewer Operations. So I'm the Operational Manager. I was with engineering for 23 years. I was the project manager and designer for a lot of projects that we've mostly successfully completed in the county. It's always, afterward, you always feel somewhat dissatisfied with how things went. But you know, the Department of Public Utilities is an interesting organization because, you know, our whole county is a single government, and the Department of Public Utilities is chartered separately from the rest of the county. And I think the reason why our forefathers did that, and it was a kind of a stroke of brilliance, is because I don't think they wanted politics to influence what is normally in the private sector. So it's like a government chartered corporation. Colleen already had a lot of great questions about how did that happen? How, you know, so it works very well. There have been some, you know, opinions and attempts to join it back to the county so that the county could have more influence. But in fact, the county does have influence because we're overseen by a public board, and eventually the county council as well. So there's two levels of county oversight. It's not like we're in this vacuum and we can do whatever we want. That is absolutely not the case. So, you know, but with the first level of oversight, the Board of Public Utilities is chosen by board members and the council, and it's a body that is constituted from county citizens. So there's a lot of county oversight. We still fall underneath county personnel rules, payment structure, pay structures, and procurement rules. So there are still a lot of the county things that we still have to, fall under, and rules that we have to follow. But generally speaking, we do have to operate like a corporation. There is not a profit structure. Everything that all of the income that the public utilities make have to go back into the operation, capital projects, upgrades, so forth. And there is in the county, in the utility charter, sort of a franchise fee that the public utilities pays back to the county, but the county council and, you know, through a lot of debate and analysis, they realized, you know what, public infrastructure should probably keep the money and put it back into the infrastructure. So really there's been kind of the funny exchange of money where we pay our franchise fee and then the county kind of gives it back for certain projects, which is I think it's been a very wise choice. All right, so the topic of this talk is the conservation and reduction dilemma. So, you know, we want to reduce our use of things, be aware of our footprint on the planet, but what does that do to our economic and management challenges? So the topic here is conservation and reduction dilemma, economic and management challenges to meet utilities infrastructure needs. So everybody knows that infrastructure has to be managed and paid for and upgraded. So we all understand that our own consumption habits have an effect on the quality and availability of the resources we consume. I mean, we have a footprint on this planet. But did you know that actually our attempts to reduce and conserve also have negative effects on the quality and availability of the resources we consume? This is a dilemma we're facing in utilities today, asking people to conserve while still trying to make ends meet with paying for our utility needs. So today we'll discuss the effects on our utility resources from our consumption behaviors, and what the short and long-term effects there are as we move toward a more conservative approach to consuming resources. We all understand that the world's population is kind of nearing a tipping point for existence on Earth. There are only so many resources available to meet humans' needs. So, you even kind of look at on a local scale, our presence up here on this beautiful plateau has a higher impact than if we live down in the valley. We're in a more dense area where it's easier to draw water from the ground and serve gas and electric utilities. Coming up here, you have more miles of pipeline. You have to pump the water. People don't realize our wells are like 8 and 10 miles away and 1,500 feet lower than where we are now. And then we have to dig wells that are over 1,000, 2,000 feet deep. So you got to bring the water up to that level, and then you got to pump it multiple times to get it up here. And then because of our topography, there's just all these miles of line that have to go all the way up here, and then we use the water, and then it has to go all the way back down into the canyons for treatment. So we have a higher, I think we have a higher sort of human footprint by just living up here, and so that it's kind of an interesting, dilemma that we face up here, that we have to have all this infrastructure to meet our needs. And the more we humans consume, the more impact we have on our planet. And the same goes for us. The more we consume, the more impact we're going to have. But that's kind of the dilemma all over the world, and it's exaggerated for us a little bit up here. But we'll talk about that a little more later. But speaking about the population of the world, there's certainly an issue with the more humans there are, the more exponentially we're going to need. And I've been reading, there's a lot of data and news about places like India and China. They're starting to see unsustainable impacts to their own populations because their populations are so big, and they have limited resources. And already both of them have to maintain these reluctant, sort of tenuous relationships with countries like Russia and North Korea, and those countries, there's a toll to be paid, when they're helping you meet your resource needs. I mean, those countries ask for something back. So how long are those relationships going to last? And also, how long can populations that large keep degrading their own environments and sustain themselves? India, and to some extent parts of China, they have heat that's so intense that it's going to become uninhabitable in the next 10 years. And so it's putting a really big strain on their population because they require this immense amount of air conditioning, and that puts a strain on their power grid and power production. And how is power produced? Coal that's coming out of North Korea and coming out of China and Russia. So it's just pumping more in to, sustain them in these super hot environments. So it's like they're on this teetering point of how long can this last, and so it's like these negative feedback loops that just continue getting more and more negative as time goes on, and there's more population doing this negative thing. Locally, we're also having to confront things like politics and climate change, evolving consumer habits, management decisions, and economic issues that affect our water and energy supply, just like everywhere else. And then not just the water and energy supply is affected, but the infrastructure to distribute it, and then the quality of the resources. I mean, we have to think about water quality and our air and things like that. So no matter where we sit on the political spectrum, these challenges are presenting themselves in a larger and larger way, and critical decisions are having to be made. I mean, even Texas has had to confront these issues. They're seeing these extreme swings in the climate. It gets, the polar. I don't know if anybody read recently in the New York Times. They were like, why is the South seeing these huge negative, low temperature swings? It used to be more consistent. Well, what happens is there's a scientist that's putting together a kind of a hypothesis, or I guess she's starting to come close to proving it. Gene, you may know more about this, but the polar vortex that sits more in the upper latitudes now has weaker and weaker boundaries, and so you see these polar vortex cold air masses coming decoupled with what usually stays at northern latitudes. It's slipping off the face of the earth and hitting these areas that shouldn't be seeing these extreme swings in cold temperatures. And so another negative feedback loop. Our climate's sort of becoming unpredictable. And so Texas has, like, you know, this intense heat all summer, so all the air conditioning's putting a strain on their utility grid, and then suddenly they're hitting negative temperatures. Like in the span of a month ago, it was in the 90s. Now it's below zero. So their power grid got strained so badly. What was it, a couple of years ago? Was it 2 3 years when we had that? Yeah. And so they had that again, and luckily Texas made some good decisions. You wouldn't think, but there are a lot of smart people in Texas. You know, people in the South are as smart as anybody else, but they realized that they needed to make some changes to their power grid, and they did. They brought a lot of renewable energy online, and so they could have distributed generation, microgrids, things that they could cut off places on their grid so that they didn't have rolling brownouts and blackouts, and they were able to meet their energy needs with all of these renewables. So that was kind of a positive story out of that. And of course, we're all aware that consumers are increasingly wanting and requiring electric vehicle charging capabilities. We're starting to see more electric cars. You know, that's driven by a certain, you know, financially secure segment of the population, people that can afford electric vehicles. And it's a major consumer shift that requires, you know, a lot of large-scale infrastructure management kind of decisions. And on top of that, you know, a large segment of the population, you know, through political and management means, you know, they want to eliminate consumer and residential, industrial and residential natural gas. I don't think it's going to happen in the industrial world quite as quickly as it might happen in the residential realm, but people want to see natural gas go away. And even locally, we have certain initiatives being put forth. We actually have a carbon-free plan here in the county to eliminate natural gas. That presents a dilemma for me because the oversight of our natural gas system is only getting more and more complex and stringent. So we have to keep investing in it as if we're going to keep it forever. You can't just like slowly let a gas system run to fail. I mean, a failure in a gas system, as you can imagine, is a failure all the way around. So we have to keep investing in it as if we're going to keep it forever. And that is kind of weird because it's like, well, it's going to go away in 2070. How much do we want to spend on it? But you have to keep spending on it. But these kind of emerging consumer changes are creating massive ripples, or really waves, throughout the whole utility industry. And the big question here is, how will utility companies meet these new consumer demands? This is a big question. Another issue is that there's also this opposing kind of point of view that they're not supportive of making the transition to electric-based utility consumption, like eliminating natural gas for things like home heating, cooking, and certainly not supportive of like community electric vehicle charging stations. And, you know, they do have a point, so it has to be considered at some level. You have to put yourself on the other side of the fence in this debate. So you have to consider, it has to be considered in the short term, the fact that as of this point in time, we don't generate the bulk of our power using carbon-free or renewable sources. We're still generating power, or bulk power is what we call it. When you look at a power profile, you see how much of that power profile is from what different sources. So the bulk of it's not produced using renewables or carbon-free sources. It's produced mainly with coal and natural gas. There is, of course, nuclear and some hydroelectric, which offsets that, but the general rule of thumb is that renewables are mostly what we call peak shaving levels of supplying electric on the grid. We're only taking like the peaks off, but the bulk has to be produced with the old school coal-fired plants and natural gas turbines and things like that. So who pays for the cost to transition to a non-carbon based power profile? who pays for the upgrade to the power infrastructure if people want to start having charging stations all over the place? Because that's a lot of demand off the power grid all of a sudden. That wasn't there before. So who's going to pay for that to upgrade? Because right now, like here in Los Alamos, we have this perfectly, I wouldn't say perfectly, but we have a very good power grid. It's not bad. It's pretty reliable. You can look that up yourself, but you can see what our reliability factors are, and it's actually not bad. We did have that hiccup last year when we had the 2 tie circuits from LANL go out, and it was like a huge water hammer or a huge hit to our system. As soon as the entire town went out, they have to turn it on. Of course, everybody keeps their refrigerators and everything on, and as soon as they get that power back up, it just slams our system. So it found all the little weak points. So we had a rash of power line failures after that, or little components, things in the system failed, little weak spots. It found all of them. There's like little fuses that are naturally in the power lines and at transformers. But really, our electric reliability is well above the national average. So who pays for the cost of transition to a non-carbon-based power profile? Who pays for the upgrade to the infrastructure? And it should be known that it's very expensive and presently driven mostly by people who have financial means to purchase and use electric vehicles and to transition to electrically powered heat pumps. For the near future, most people will need to continue relying on their gas-fired boilers and their water heaters and probably even cooking stoves for a while. I mean, we're trying to get a public initiative out, or an initiative out to the public to get people, as soon as that goes out, could you start thinking about replacing it with this other type of, more something that's going to be useful in the future. I always tell people, you don't watch like Star Trek and Star Wars and see those, spaceships coming into a gas station, in space. I was like, I hear your argument, but at some point we're going to have to go away from that, but what happens in the near future? How do we pay for that? Because it's very expensive, and it's getting more, relatively more expensive faster than other things. So the cost to update utility infrastructure outpaces what normal inflation is. And it's a dilemma for power utilities to pass these costs along to all of the consumers to upgrade, the distribution system to support home charging stations and fully electrically driven appliances. New modes of funding these projects will need to be explored, and it can be done, but it has to be recognized that the ability and wants of the few, although the few is now becoming more of a majority, but these are, again, at the moment, people that are usually more financially secure and willing to do it. It needs to be recognized as such because the general consumer and population just can't always bear the burden of the cost right up front. But it should also be noted that a big caveat of this debate is the need to transition to cleaner power production and elimination of emissions by gas and diesel-powered vehicles and carbon-fired power plants, because our environment can't sustain that forever, and we know for sure that there are negative effects of pumping all that carbon into the atmosphere. So it's a cost that is borne by all of us, right? Because the planet belongs to everybody. So the burden of the cost does have to be spread throughout all of the population that consumes.
Do you have questions at the end?
Let me finish one more. How do we equalize that for everybody who, there are people who can pay for it and people who cannot. So.
Perfect segue to my question. There's a bunch of federal money available through the Inflation Reduction Act for electrification. We haven't talked about this.
Yeah. No, you're right. So, yes. Yeah. So I'm putting all this out there to get you thinking about these things. Like, we're going to have to start thinking about how we're going to pay for this and other types of utility infrastructure. So this kind of leads me to part two. So hold that thought because this all ties in. So part two of this, now we're going to go to talking about water infrastructure. And it's another arena of public utility challenges, and that is our water and water resources, drinking water and surface water, just water in general. Water utilities also have this parallel set of challenges that are also influenced by politics, management policies, climate change, and economics. Water utilities also have some unique challenges in terms of infrastructure and long-term supply. I think it's well known that throughout the American West, and now, even other parts of the country, I've been reading how droughts are starting to occur back east in New England, and I just thought that was crazy. There are definitely some serious drought issues in New England and Michigan, which I find to be just, I can't believe it. But it's the heat and drought is becoming an enormous problem. And each year, some areas that rely on either surface or deep water wells, or both, are seeing a deficit, and it's compounding every year. I really won't go into people's consumption habits, but it doesn't take very high-level observation skills to, when you fly over Las Vegas or Phoenix and you see all those swimming pools and fountains and all of that out in 110-degree heat all the time, and all those golf courses. That water's coming from somewhere, and it's taking it from places that it's not being replenished at the same rate they're taking it, let's just say. And I think, it's well documented, Lake Mead, Lake Powell, they dropped to historically, incredible. They were almost down to what they call low tub. It wasn't even going into the penstock intakes anymore at those dams, so that was very frightening. And locally, we also see a decline in our source of water, which is, if everybody would kind of take one of the handouts, I probably didn't bring enough. But we get our water from the northern New Mexico unit of the Rio Grande Basin Aquifer. Fortunately, we are in what's considered an open recharge portion of the basin that does see recovery when there are wet periods. The recovery, so Steve, we were talking about it, I was like, this is the aquifer, it's not the watershed. So the watershed is much more broad, yet would be a different overlay. So the watershed, for our portion of it, is we see recharge in the northern New Mexico kind of upper reach of the Rio Grande, not the Colorado, but the upper northern New Mexico reach of the Rio Grande aquifer is recharged by a lot of the precipitation that falls on the Colorado Plateau. So that's why everybody here in Los Alamos, we're good, we've got plenty of water. Well, we do have more water relative to other New Mexico people, but it's finite as well. And when's the last time we saw a 3 to 5 year wet spell with huge surpluses of water? It hasn't. It's been a long time. And so with that, we have to start thinking about our water use. So we here at the Los Alamos County Department of Public Utilities and other forward-thinking water utility providers, we're not the only ones, but it's not a universal thinking process. We've embarked on an initiative. We've embarked on an initiative. It's a relatively new initiative to start conserving our water, and asking consumers to reduce their consumption so that we can find more innovative strategies and methods to reduce our pumping of groundwater. Pumping our groundwater from our deep water wells has steadily drawn down our aquifer on an average of 6 inches per year. And so that's been the average since we started, 6 inches per year. And so, that doesn't seem like much, but you project that out over the course of our history of inhabiting this plateau, it's going to start adding up. And so that's the average trend line. Some years it's more and some years it's less, but that's the rate of what we call aquifer drawdown. We have 13 well sites, and at those well sites we put down deep well downhole pressure transducers. It's a sensor that when put under pressure, it has like a strain gauge that sends a different amount of current out depending on how much pressure is on that little gauge. and it lets us know how much pressure. So we put it at a known level, and then that's our baseline, and then every year we kind of watch that level change. And so we have a trend line on all of our wells as to where they're going. All of our wells are connected in some way. I mean, there's hydraulic pressure. They do different things. They have different characteristics. And our water production crew, after some of them have been here since the day the county took the system from DOE. They've been here since that day. We still have those same guys, and some of them even worked for DOE on the system before that, so they're well aware of all of these wells and the characteristics, and it's kind of interesting to get that, old guy knowledge from them and hear what's happening with this well or that well, because every well is like a person. They all operate. Some of them are gung-ho and they give you everything they got, and some of them you're just not going to get a lot from, and some of them you don't even turn that one on. It's useless. And so, and that's the way our wells are. The Guaje wells are very temperamental. They're from a more constricted, I mean, it's not confined, but it is a constricted piece of the aquifer. Couple of them do pretty well, but there's 5 wells out in the Guaje Canyon, and some of them are on their second generation. The DOE actually re-drilled 1, 2, and 3, and 4. So they're all on their second generation. The second generation Guaje Well 1 no longer is functional. It finally has collapsed and cratered in, so we don't have Guaje Well 1 anymore. We have all the equipment, everything there. We're trying to decide if we're going to re-drill at that site. You have to kind of drill, like just move over, because, it's the formation sort of collapses in. So Guaje wells, they don't recharge as quickly as the wells in the Pajarito well field all along Pajarito Road. Those wells are very good. We have Ottawa 4 down in LA Canyon, pretty far up LA Canyon, and it's the one it pumps water straight out, and it pumps all the way up to Anniversary Tank right away. So the Anniversary Tank out here gets water from down in LA Canyon, and then we have to boost it from there. It's a great performer. The problem is it's a lot of old water line that goes like underneath everything important in town. I don't know why the government did that, but they put the big transmission water line all under Central Park Square, right through Bathtub Row, right underneath Fuller Lodge, and so it's getting old. We're going to have to replace that, and we don't want to blow all that water into Fuller Lodge, right? So that's a problem. Ottawa well number 1, which is at the bottom of the front hill, you see the old that old building and that old tank. That's a booster station. We don't use that one anymore because we have the pipeline that goes underneath the front hill road used to break so often that we were like, oh, forget it, abandon it. So that booster station just sits there. It's not really running. So we rerouted the piping from Ottawa Well 1, which is not an old well, and it has that newer tank off the Front Hill Road. We routed that water around to like the truck route into that pipeline that eventually goes to White Rock. And then Pajarito Tank 1, which serves White Rock. So all the water out of that White Rock people use comes out of that Pajarito Tank 1, which is you can see it when you're at the Church of Nazarene, right there at State Road 4 and Grand Canyon and Pajarito Road. You can see the tank. So that's White Rock's tank. So the wells actually pump all the way to that tank. So White Rock kind of is closer to where the water that gets produced. They're closer to their water. Up here in town, everything needs to get boosted multiple times. But Ottawa Well 1, you can only run for a few hours before we get like a cone of depression, and the transducer starts telling you, we're suddenly low on water, and we have to turn the well off. It's maybe like 7 or 8 hours. Karen hears all this. She knows all of these wells too. We have to turn that one off and let it, let the bucket level come back up. But then we can turn it on 2 days later and then do the same thing. So every well is different, and these guys all know it, how each well works. But water infrastructure is so costly and complex and difficult to operate and maintain. There's just all these, it's like a never-ending array of things that you have to know and have experience with. And, you think you know everything after 25 years, and some new, I have never seen that. And you'll like call the old dude in Albuquerque who's like, oh, I know everything. He's like, well, I've never heard of that. And you're just like, man, I thought I had this figured out, but no. So, I always laugh because I'm like, man, I have a job, this is important, and I'm like, my dad should have this job, not me. But eventually, you're like, well, you're it, and so you have to figure it out. But one thing's constant: the cost to operate and maintain the system, which consists of a lot of different subsystems, is very high, and it's increasing at an accelerated rate. This presents another dilemma to the utility provider, which is us, DPU. How do we pay for the costs to replace the infrastructure and maintain it, especially when we are asking people to conserve? I mean, it's kind of a weird business decision dilemma. In a normal business, selling more product usually equates to success, right? You're trying to get people to buy more of what you're trying to sell. So, you see it in advertisements, you want people to buy stuff. But what kind of business model discourages people to buy less of a product that you're trying to sell? It's a weird problem. And it requires considerable strategic analysis and planning for the future. And we're starting to actually realize a significant reduction in water consumption per capita. It's actually starting to be noticeable. People have begun to reduce their water use, which has resulted in decreased demand during some parts of the year. We do see this kind of big spike during a climatologically hot period, especially in White Rock. People in White Rock still tend to have quite a number of people still have fairly big yards, and so it's hotter down there, and so people water their yards twice a day. Still some people in Barranca Mesa, some of the older houses with bigger properties, and people have big yards still, and so there is a spike in demand, but it's more of a spike rather than a long, broad hill, let's say. And so because we have that spike and we don't ever know when it's going to happen and when we're going to have, it's hard to budget. Like, how much can we plan on for capital projects and O&M expenditures, like replacing a piece of equipment or something like that. But generally speaking, even before we began our quest to get consumers to reduce their water use, the cost to produce the water and distribute it to you, the consumer, was going up at a rate that was and is still higher than the average rate of inflation. And then COVID came along, and it put everything, it stepped us up to yet another level of cost. And that really hasn't come back down. We keep hoping in this industry that operation and construction and all of that is going to normalize, but it really hasn't, especially with electrical gear and electrical materials. It's just very expensive, and it's resulted in an increase in complexity to plan for and budget for capital improvement projects, and not to mention how to own and operate, preventive maintenance, things like that on a daily basis. And then people, people complain about the water line breaks we have, and we do have water line breaks. I mean, that's any community has them, but we're in a really interesting area with weird topography. Big changes in slopes and aspects here and there. It's just, the problem is it's just too costly to go out and just start replacing water lines. It's a lot cheaper just to fix them, and it's not a problem until you start to see a pattern of recurrence, and it's like, oh, this thing breaks 3 times per winter, it causes this huge ice sheet, and there's somebody with special needs over here who has to get out at 7 a.m. and you've got all this, you start to put all these things together, and then you're saying, all right, it's time to replace water infrastructure. And just for reference, this whole downtown area is about to see a lot of water upgrades because it's starting to show its age and issues, and the fact that they didn't put any valves in when they did. I was like, you have to isolate such a large area anytime there's a water issue in downtown, and it just happened just a couple of weeks ago behind Bathtub Row. We're like, how do you turn this off? And our guys are scrambling around, walkie-talkies and cell phone's trying to, oh, is it off? Is it, nope, is it off? And you're just keep going out into a larger and larger area, and they're really good at it, and they can do it pretty quickly, but it's still, you don't want something like that to happen in the middle of the night on a morning or when it's below zero or something like that, and it affects people. But it's just so expensive to replace them, and it's a big impact to everybody. I mean, I live here too, and God, I hate all this, cones and barrels, and it drives me nuts. But anyway, we try to put together these plans that are okay. This makes sense now financially. It makes sense in terms of disruption to people. It's time to do it. And certain components in the water production system. Let me see if people are. Yeah. Certain components in the water production system, which are wells, booster stations, tanks, and et cetera, they have a functional life, and you have to predict that. And those are things like electrical motors, the motors driving the pumps, motor control centers, the things that control the motors, communications and controls equipment, and the software that runs all that, because it's like a big giant robot. The whole water system is this really interesting, complex thing that has to check, is that happening? Yes, then do this. Is that checking? Yes, then do this. So it is like programming the movement of a robot. But all of that stuff has a lifespan, and it has to be predicted and replaced at some point, hopefully before they fail. Predicting those end-of-life moments is a whole science unto itself. And it takes a lot of experience and calculations to figure out how to do that. We have to get outside consultants that then usually just take all the information from us and then produce a report that we give to our oversight boards. That's pretty much what we knew, but you have to say, well, I didn't just make this up. Moles and Corbin in Albuquerque also say the same thing. And we're currently facing quite a few of those moments and the need to pay for all of that system. Like I said, we inherited the water production system from DOE LANL in 1999, and some of it had been well cared for. Some of it was fairly new, but some of it had issues that came along with it, and we're still dealing with that today. We've operated and maintained it for about 25 years now in the county. We have developed our first well that just got commissioned this last year. So the county has only produced one well ever, and that was a big deal. Believe me, it was a lot of work. And some of the wells that we still have running were developed and installed and developed in the 1960s, and they're still functioning, but definitely in need of a lot of upgrades and replacements. For reference, the Ottawa well number 2, I think, ended up, when everything was all said and done, it ended up costing about $8 million. So it's a lot of money to develop a new well. So keeping the wells that we have running is very important. Paying for all of that infrastructure is an issue, especially when we're reducing our water use. And we've analyzed our costs to produce and distribute the water, what our future needs and costs will be, and what it'll take to pay for it. These analyses have pointed to the fact that we'll need to increase the price of water for several reasons. And I think some rate increases just ended up coming through in October. Yeah. And I've seen in like social media and heard directly from people that our policy to encourage water conservation is stupid. Like, why would you do that? You're just shooting yourself in the foot. Because they know that, we're raising rates and we're asking people to buy less. And it's like, well, let rich people with big yards buy more and that'll help pay it. That's not the solution. And they do wonder, why don't you just do that? And it's like, well, I think there's a pretty simple answer here. And, the main one is our water resources are finite. They're not expanding. They're going down here in the American West. And so that's the most important factor here. We can't ignore the fact that we're drawing our aquifer down. The West is getting hotter and drier. And then you couple that with the fact that there's a lot of wear and tear on the system when there's higher use. So the more we use, there becomes a point at which it starts to become more costly because the well motors and all the piping and everything starts to take. It's like driving a car. It's like driving your car off-road a lot. Let's put it that way. So the more you like hammer your car down a washboard rutted road, the more wear and tear and expensive it is to operate that car. That's how it is with the water system. The more you do it, I mean, every time you turn all that on, that our water wells operate at either 480 volts or 4,200 volts. The 480 volt ones draw more current because, you know, it's lower voltage, more current. The bigger ones that have the 4,200 volt, you know, that's a lot of voltage. They draw less current, but they usually are driving bigger motors. So the electric motors, they take up whole rooms in here, and like in here, and you know, you go in there, and this electric motor, it's so loud, and you can just hear the electricity, and you feel the back of your, and you're just like, oh man, this thing is scary, and so these motor control centers slowly step the current draw up. They bring because you know that pump shaft is like 1,500 feet down, and it has multiple stages of these turbines to boost the water through them, you know, at 3,200 RPMs, and it's moving like anywhere from 800 to 1,500 gallons per minute up that 1,200 foot shaft, and that, you know, that shaft has to turn down there, and it's moving that weight of water column. And it moves a lot of it. Like I said, 800 to 1,200 gallons a minute. So when you turn that thing on, you can imagine the electrical hit. I mean, it's like getting a sledgehammer and just like hitting the concrete floor. You know, it's just this hard hit. So these motor control centers slowly bring the current up and get that motor turning and get it moving so that it's not just what we call across the line, you know, hammer hit, you know, bringing this humongous inrush of current, which is a stress to the entire power grid. When you do that, you get this huge voltage and current spike that then normalizes once the water gets moving. So everything, when it's at locked rotor, that causes this enormous stress on everything. And there are these components in these motor control centers, and some of them use these wide delta transformers, some use these resistor coils like Frankenstein, and you get near it and you're like, get out of here, don't be around that thing when we turn it on. And you think about it over the number of starts and stops over the lifespan of that thing, and you know, it's a lot of wear and tear on equipment that costs a lot of money. So let's see, where am I? So yeah, our water, there's a lot of wear and tear on the system, costs a lot to upgrade it, and so, you know, you wouldn't want to drive your car like that. So that's kind of how we are with the water wells. But there are means by which we, as a ratepayer structured utility, do cover costs. You know, you have to get creative while still providing service at a reasonable and locally competitive rates. We've done a lot of market analysis, and we realize that we are still competitive. Espanola, Rio Rancho, Albuquerque, Santa Fe, certainly we're lower than them. But firstly, we need to understand that no matter what, you know, water's a commodity, and we have to pay a certain market rate for our water as a consumer. Everybody does. We've been able to maintain these competitive rates here, and even though we require more utility infrastructure per capita than just about any other community in New Mexico, which are more miles of line per capita, multiple wells, boosters, tanks, pumps, etc., because we live up on this sloped plateau here, we can still maintain good competitive rates by having very good in-house staff, good management, good public oversight. We don't use contractors for most of the things we do, except for building the infrastructure. We use contractors for that, but we don't have to outsource our water O&M to a company like Las Vegas, New Mexico. They have to pay companies to come in and operate their stuff. And we do more. We do need more individual customer accounts. So, you know, people are like, well, these plans to put in more housing, isn't that a problem? And in fact, in my world, I look at it like I actually want more individual customer accounts. I would rather have more people paying to have the ability to use the water and then not use it very much of it, right? So I need more customers who are water wise. That would be better. Same with the gas system. So that's really kind of our what our hope is that having more high density housing gives us more customer accounts to help even out the spikes and shocks. We know how many customer accounts, we know what our budget will be from year to year, and we know that we won't have such a larger demand, hit to our, the wear and tear on the infrastructure. So many customers who pay for the ability to use water without actually using it is a good thing. Finally, we at DPU, we do pursue a lot of grant opportunities we're looking at a lot of grants for the EV charging stations, any grants we can get to upgrade the electric grid, things like that. But luckily, the EPA and the NMED are both very good organizations. We are very fortunate. I think that you wouldn't believe it from somebody, but we have a very good state environment department. New Mexico Environment Department, they have very good people, and they're very proactive. They have a lot of outreach. They encourage all of the water providers around the state to apply for their grant and funding mechanisms, and they have good people that oversee those projects. So we have gotten very aggressive about going after whatever program monies there are to do infrastructure upgrades for both drinking water and clean water. Clean water is different. That's like a drainage, and like the reservoir, that's a clean water grant, the reservoir project. But mostly for our water and wastewater, those are called clean or drinking water act programs. The projects though have to be pretty much ready to go. They have to be, shovel ready. Like they don't want to see, well, maybe we're doing this. It has to be very clear, well defined. That they are on top of you about that. You have to be very organized and ready when you go, because you have to go and stand before all these oracles at the state office of the Water Trust Board, and you're like, please, kind sir or ma'am, and they're like, why do you need this? And it is kind of intuitive because it's at the state capitol, and you go in there and you're like, we have a golf course that needs more water, and so sometimes you have to be pretty creative on how you put those presentations together. But the projects fall into several different categories and are reviewed by this board, and it's a board of all people from around the industry, and they include, water managers from the pueblos and things like that. So it's a really cool experience and very diverse when you go in front of them, and they have all kinds of different questions and points of view. And of course, being Los Alamos, they're like, oh, why are you in here again? And they're like, what is this for? And you're like, it's just for people. So there are those kinds of moments when you do that. And so, like I said, some are through, there are different grants and funding mechanisms, and some of them are low interest loans, and some of the loan that they're different. It depends. You get a different interest rate depending on what's going on. But some of the loan programs, they'll put this out, and it's like less than 1%, and so that's almost free money. And so we go after those anytime we see something like that. But even a low interest loan, like say it's like 3% or 2%, if it's a big enough project like the new White Rock, we call it the Water Recovery and Resource Recovery Facility. It's no longer wastewater. You don't call it wastewater. No water is wasted in New Mexico. So the funding for that at first was 3%, and that was going to be massive because, a project that at first was $14 million went to $17 million. Then we realized, we better bump this up. We had the COVID thing, and we thought, $25 million, that's all we're going to need, we swear. And we kept running to the state. This is all we need. This is the last time we had. And then all of a sudden we're like, ooh, it was $30 million. Can we have 30? And actually they understood, and they changed our loan every time we went and said, we have this problem, it's going to cost this much. They came up with solutions, and then like a few months later, we restructured the whole loan, and now it's less than it's less than 8%. But when you amortize $30 million out over 30 years, it was a lot that the ratepayer here in the county was going to have to pay for. So we were very fortunate that the state lowered the interest rate on that one.
Sorry to interrupt you. They're going to have questions for you. I don't know how much more.
I'm almost done. I'm really done. So, yep, I'm almost done. So anyway, somebody has to pay for all that. So what types of infrastructure issues do we see here in Los Alamos, and what's a general condition assessment of our system? There's not a single answer to that. Generally speaking, we have a pretty good system, but it does have problems, and we know what they are, and we know, that age is a big part of it, and we have a plan, for 10-year, 30-year, and so forth. And so we keep that initiative, we keep the fire lit under those programs. But one major issue that I wanted to talk about that we do find is underground, it's in leaks and breaks, it's corrosion. And I'm going to pass these around. These are bolts that are fairly new. Pass these around. These are bolts that came off of fairly new valves. After the Cerro Grande fire, we had the burn area project. These, in relative lifespan of our water system, these are less than 25 years old, and the corrosion is coming from, we don't have corrosive soils. It's coming from intrusion of salty ice melt water. So the salt that we put on our roads is just eating you can see it eats up the roads. You can see it eats up the sidewalks. It's eating our water system fast, and it's accelerating very quickly. So one of those is from the water, the valve that blew out in Camazon, 2 years ago? There was that huge Camazon blowout in the middle of winter. That was horrible. We had to close down the main road into Camazon and dig that up, and we found that anything that was uncoated was just eaten away, and that's not very old. And then the other one came off of North Road across from Urban Park just this last summer. And that's what we find. That's actually not very old. So the saltwater intrusion finds its way through the valve boxes or into the trench lines, and it'll travel along, and wherever it sits, and if something is uncoated, it'll eat it up, and it will get a big water blowout. And then a lot of the old stuff around town, we dig it up, and the bottom of the pipe is just gone. And it's because the salty water got down under there, sat there, and ate it away. So what happens is salt is notorious for eating up, metallic carbon bonds, and then with concrete's a ceramic, it breaks the crystal bonds between the concrete, ceramic, and the aggregate. So it'll break that. So you just see all the concrete. Just even if it's not very old, and older concrete is more resistant to it. New concrete, it's not at all because it hasn't had time to fully hydrate and set. And then, of course, asphalt, the covalent bonds in the asphalt are broken up by the water, salt. And so in New Mexico, I don't know why you don't see this as much in other states as you do here. We use a lot of magnesium chloride to melt the ice. I know people like dry roads, but it does come at a cost. And then there have been a lot of research into the fact that all this salty water is starting to get into our surface and groundwater too. So it may be something that we have to start taking a closer look at, because we're seeing more and more waterline failures due to the ice melt salt. But that's not the only problem. We do see age, wear and tear, water hammers, the way our system's configured, long runs. We don't have a looped system that water hammers have a place to go and dissipate. The water hammer will travel down Los Pueblos and break a line somewhere out there if something happens. So the fact that we have all these what we call dead-end runs, they have false loops on themselves, but that doesn't dissipate water hammers. Those will break water lines. So with so many unique and interesting attributes to our water system, we do have infrastructure issues. There's a whole bunch of other stuff, like things that our software to run our system needs to be upgraded. The controls and the radio system needs to be upgraded. Those are all things that you don't actually see, but those are things that we have to put together. I think I've covered just about everything. Just, the sort of to summarize, we've got to come up with these ways to fund ever increasing issues, and it's got to be fairly creative, and whoever follows us has to keep the ball rolling in finding these funding mechanisms. All right, so I'll take questions now. All right, we have. I'm going to fail the quiz. I don't remember everybody's name. I recognize some people.
Does the DPU and or the county have any plans to say, all of us, if we get to a certain point, you must do certain things to conserve water?
We're not at that point yet. We are starting to have to plan for lowering. We have the ability, so wells are always dug much deeper than you set the pumps. So we still have another, in most of our wells, we have like another 500 to 1,000 feet of aquifer level that we can keep lowering the pumps. And we are starting to see that kind of out in the Hawaii, because we will see this like drawdown, and then we start to see things like arsenic come into the water a little bit. It's still under our contaminant levels, but all of a sudden arsenic that wasn't there, all of a sudden it's detected again. And so there are those kinds of things. So we have tried to, okay, when we start to see the arsenic, don't use that, turn that well off, let's use it and blend other things into it, just because I don't want to, I live here, I don't want to have arsenic in my water. And even though it's well below the EPA, but we're not quite to that level, but I feel like that time is coming, and it came for people using water out of Lake Mead and Lake Powell. And
10 years, 20 years, 5 years?
That's hard to predict, but at 6 inches per year, it's probably going to be 70, 80 years. But, yeah. But yeah.
A question that I hate to ask. Security, both physical and external.
Yeah. Mm-hmm.
How vulnerable are we in our infrastructure to outside hackers or to physical?
So our control systems are not, they're on a dedicated, we call it black fiber. It just goes into our own system. It doesn't go out over the internet. It's not something that can be hacked into. Plus, it's so complex that only people who know, it even takes a long time to train somebody in how to do it. But I know that doesn't really answer the question. But it goes behind multiple firewalls, and it's only its own thing. It's its own standalone system. But there's really not we still have a fairly manually, the operator still has to go out and drive around and do all, you'll see, we've kind of left that in there on purpose, but we are having to do things like so we need to put now fiber optic rather than radio communications into systems so that we can now have cameras, and see, we have a webcam that we can see what's happening in the wells. We have intrusion alarms now, and we know, so we can tell what's happening in the well. Somebody has entered there, and if they're not authorized to do so, we know that. But we do get vandalism, like down in Rendia Canyon. Like people have messed with stuff, but they couldn't get into the stations or anything like that. But they've stolen power wires and shot something. Yeah, we get that. I'm sorry, I'll come back. Yeah, go ahead. I'll go ahead and
Okay.
which yeah.
So
Andrew.
first, thanks for your opening view of the whole world.
Yeah.
And the
Well, it affects us. Yeah.
It's really important that we all know that and think about it. So thanks for that. And then I'm not sure if you mentioned what percent of our energy supply is solar, but I just wonder if there's more that we could do with that, like covering the tops of parking lots or buildings. I know we have the huge solar thing over in the old landfill. Anyway.
Yes, no, you absolutely can influence that. That's why we have a county council, and we have a public board of utilities. There's the LARES, the LA Resilience, environmental sustainable. Yes, so there's a lot of things happening with that initiative, and there are a lot of initiatives that need to have kind of a response from us, a plan. And, in our strategic planning, we're like, what can we do? So, I have a colleague, he's Ben Olbrich, he's the deputy utility manager for power production. He and Philo have to make sure that occurs. We're all involved in it, but your involvement, like just the fact that you're here and people know who they're voting for and what they stand for and things. So, it's this long chain. It's a loop of things happening. So knowing who you're voting for and what they stand for, are they for these? But it has to be balanced. Like you can't just say everybody needs an electric vehicle tomorrow. That's not the answer, all right? It has to be done in a balanced manner so that it's sustainable at the pace we can do it. Because, like I said, the problem is, how do we pay for that? It's going to take time, little steps, but those initiatives are good because it says, here's the path we're going. Our voting body has voted for these people who have made these decisions, and this is the path we're taking. And so that's how it's going to occur, a little bit by little bit. I'm going to hold your question, David, because we have one up here. Go ahead.
But it just has to do with our rate structure, and I'll try to make it simple. But it seems as though that we run into problems when people are concerned and we don't have enough income to pay for the infrastructure.
Mm-hmm.
And that's because we're charging so much, we're putting so much on of that rate recovery into the commodity rate. So
Yeah.
Is there a way to not have, because our water basically, the water itself is free. It's not like gas we're buying from somebody else.
Yeah.
It's basically free, but we're charging people based on their usage and we're putting it into that commodity rate.
Yes. So we've put a commodity rate. So there is a market charge for water. We know what it is. We know that water costs this much wherever you go, and so we know how much it costs to produce it. So that's our own calculated commodity rate. So we have to actually assign this commodity rate based on how much it costs for us to produce it and get it to you, the consumer. So that's the commodity rate. And then we've tried all different types of, tiered water rates and things like that. And it turned out to be fairly unpopular. But I think at some point in the future, we are going to have to go back to considering a tiered water rate. If you're still watering, your 5-acre plot wholesale, with big giant rainbird sprinklers, hold on, you're causing us to have to produce a lot of water just for you, and it's going through all of our appurtenances in the system. So we don't have that yet. So everybody has seen this. We have this long-term rate increase structure that we have, and it's you can look that up. It's open knowledge. I mean, so we just know how much it's going to cost now and in the future. So we had to project how much these water rate increases, and they were high at first to get us over the hump that we had. Now with gas, we were influenced by world politics, world things. The war in Ukraine caused every country no longer could buy gas from Russia. So the demand for natural gas suddenly spiked even here in the U.S. Even though we have tons of natural gas here in New Mexico, it doesn't matter. It's a world commodity. And so we could produce our own natural gas for free. Same thing. That gas, it comes out of the ground whether you want it to or not. And people were like, wow, we have all this gas here in New Mexico. And I was like, doesn't matter. If somebody's willing to pay this much in Germany, that's how much this corporation here in New Mexico is going to charge also. And that's what happened. Water is more of a local thing. The water that's produced here gets used here. It's not like gas doesn't do that. Structuring water rate increases has been a point of contention. I'll grab David real quick. No, I'll come back.
Quick and easy to know, what percentage of the electricity produced is used just to pump water?
It's the largest. It's 20% here in the county. So the county manages the power pool for DOE, LANL, and DOE Sandia. So the county does both. We manage the power pool for LANL, Sandia, and the county. But all the power that the 20 megawatts per day that is used here in town, 20% of that goes to water production. So it's the largest water electricity consumer, really, for the county part. Now, when DOE turns on that beam channel, we have to actually schedule special power for that. They have all those step-up transformers that pull a lot of power off the grid. Yes?
And this may be not a question so much as maybe a suggestion or something like that along those lines. I live alone in my house, and a lot of people in Los Alamos, there's single people and older people. And, you know, I've worked with contractors and done different things, even fairly major additions and remodeling. And that gets difficult. And I would like to do something with my water heater.
Mm-hmm.
You know, I think that's an area of gas where I could be more efficient and hopefully
Yeah.
get rid of it. I
Yes.
happen to have solar, so I'd love to get an electric unit.
Yes.
But I don't know how to go about that, how to start. Everybody, you know, you go to anybody and if they're a hammer, a nail is the solution. So
Yeah.
I don't get very good unbiased information.
That's interesting.
when I go out there.
So I think that's part of the LARA's initiative is to have community grants to start, because the county we can't actually give incentives or rebates. It's against the county's charter to do that. So right, but let me see if I can get to your point here. But what we can do is provide education and opportunities manners through which you can do stuff for yourself. So we do have a conservation specialist at the DPU, and she's a great resource. She's right now on maternity leave, and she won't be back until. But we still have Kathy Deanna, who is our public information officer manager, and that program is still running. So that is like a community outreach resource that can provide that information to you. Yeah.
Yes, I was going to finish up
Yeah.
with that. That's what I was looking for is the way that you're doing all this education and even some help with trying out induction
Mm-hmm.
cooking. If we could get some education on other alternatives for some of the things that we've got in the house, you know, that we'd like to replace, not just the stove, which is probably relatively small. I have a gas in hot water, but I also have a gas furnace, so just different options and something that's unbiased and just educational.
Yeah.
So that's the department together.
Mm-hmm. Yeah. Her name's Abby, and she's great. They do put some Facebook posts out because heating hot water is probably the biggest thing you do, you know, energy-wise in your house. Heating water takes up a lot of energy. So there are a lot of, I know that we've recently produced a lot of reports on what there is available for heating water. And if you have solar, there's a lot of options for you.
Well, solar PV.
Mm-hmm. Yeah. Yeah, because you can go direct. You don't have to go through like another appliance. You can actually do direct solar heating through heating coils and stuff. That's actually pretty efficient. But there's all different ways that people attack that. So you have to like pick from this menu now. And I think Abby Hayward did produce this menu of options. Are you thinking about getting rid of your old hot water heater? Now's the time. Here are your options. And so there are resources out there.
And tax incentives, what? Tax rebate.
Mm-hmm. But how do you go about it with which contractor? And see, that's an issue we have. We can't suggest contractors, but you can come up with a solution.
Take lists and, I think I probably need to come in and get a 110 volt, the 220.
Mm-hmm.
And, so I have electric work. So it starts to add up, and I just want to make sure I'm on the right.
It is, right. Yes. Yeah. So, yeah, please come in. You can make an appointment, and we have an electrical engineer who can, they'll give you different options. You could say, I'd like to see what this is. What does this entail? And so forth. Yeah.
Okay, that was helpful.
Yeah. Who else?
At the beginning of the talk, we talked about, basically, mentioned the carrying capacity of both. Okay, and I think it's like 2.5 billion, and we have 8 billion on the planet. Has the county done like a carrying capacity for the county?
Could you repeat the question?
Okay, so what is the capacity to serve? That's what we call it, capacity to serve. So, like, let's say the schools decide to develop that land that's below the middle school. How many units can go in? What can our infrastructure here in town bear to serve? That's a very good question. It's something that is definitely something that we have to analyze and calculate all the time, because we have the water to serve everybody. That's not a problem. System with tons of serving capacity, but there's an initiative not to serve people with new homes with not natural gas anymore. But then that places a demand on our electrical grid. So that's really the biggest issue is home heating and hot water heating and the capacity to serve. So that is probably the biggest issue that we need to. And traffic, yes. Yeah, so traffic. How much traffic is going to happen? That's actually a big problem too.
So we do have a figure.
Yes.
But
Yeah.
that figure is not influenced by your desire to have more customers, to have reduced rates, or is it?
We need more customers to do that. So the more customers we have, the better we can plan and budget for upgrades for everybody. The problem is we have all these fairly low density homes and some homes that aren't even occupied. We have all this infrastructure that costs, and we have a big water consumer out at the labs, and it's like we kind of need more customers. We need more water-wise and energy-wise type customers. And then we can start to do things with our system that we are not currently able to do immediately. So the more customers we have, the more we can get over this hump of having to increase everybody's rates. The more customers we have, the less we have to increase rates. Does that make sense?
So what's the ideal county population?
Yeah, that's a good question. It's probably higher than we have the ability to actually put in, because it's going. We only have so much land left to serve. People have thought about developing Rendia Canyon and all of that. That goes beyond a tipping point, because all of a sudden we've got serious infrastructure demands and environmental issues and everything to develop homes out in Rendia or beyond, like Deer Trap or Barranca Mesa, the next mesa over. That's been an idea, but I think that's beyond a tipping point. If we can infill what we have, like parts of DP Road, the North Mesa area, that will help a lot. So the current plans to put higher density homes is going to help our future outlook a lot. The county could probably use more in terms of utilities. Now we have other issues, traffic, healthcare, things like that. That's not my area of expertise, but I can see that having more traffic. I mean, it's already bad at 7:45 when you hit Diamond Drive and Orange and Sandia. How much more traffic can we bear? That's a problem. So, it's a give and take. But in terms of utilities, we need more customers. And the more we have, the better the ability to serve and meet, like electric vehicles and home heat pumps and things like that. That will improve. Now, the other stuff, I don't know. That part is a problem. We'd have to put a bigger road or have different We're also looking at the county and at LANL to go to different work hours. That may be a solution too.
And then what about the new water line up to the ski hill?
What about it?
I thought it was supposed to start this
It is. Phase 1 will start this summer.
And where does the water come from?
It's produced water out of our system. They are going to pay a higher water rate. We know that the cost to get water to them is going to be higher than everywhere else, and there's going to be a special water rate for the water that's consumed by the ski area. Because already, if you live in Camazon, right now Camazon is probably the water that costs the most for the county to produce, because it has to be pumped 5 times to get to Camazon. Some areas 4 times, some areas 3. Camazon's a 5-pump water tank, that water tank up there. But that's nothing compared to what's about to happen to go up to the ski area. So they are going to have to pay a special rate for that water. I am doing everything I can to encourage them to use the stormwater that comes into the because currently we collect the stormwater, and that's what gets pumped into that pond at the top. I'm going to encourage them to continue to redevelop that, so that, because that water is cheap, it's there, and we only have to, it's right there, so we can just pump it to the top, and they can use that water as much as possible, so that they don't have to use our pumped, treated, well, we don't treat water here, we chlorinate water, but we disinfect the water, we don't treat it. It comes out of the ground very clean. But they're going to use groundwater, pumped groundwater that we've, pumped all the way through our system, and then we're going to send it up there through 4 booster pumps. So that's a lot of electricity to get it up there. So they're going to pay more.
You could let Pete be the last person, although we'd love to keep you here forever.
Yeah.
Salt. Is Clay Moseley the guy who has sort of final authority? If our salting of the roads is causing contamination of the groundwater, it's roads and ground.
That hasn't been proven. I can't say it, but it has been a research topic.
10 years ago, the salt was contaminating the groundwater.
Okay, all right. So,
the data was clear.
all right. I believe it does.
If that's the case, who is responsible? It's kind of roads doing it, and the NMED has responsibility.
Big problem.
For standards and
Surface water.
You have somebody else has the, it's killing the trees. Who's the county person who's the kingpin of that multi?
Juan Rael.
Pardon me?
Juan Rael.
And Juan Real is.
He's the director of public works.
Okay.
It is a serious problem I can only talk about what I see. I'm a county taxpayer. I know it eats our roads up. Every time, in every single capital project, we always pour that last bit of concrete, October 31st. Oh, it's going to freeze next week. Get the concrete on. And, they got that blanket on. And then 3 weeks later, salt. And then the next, what is wrong with the concrete? They just don't make it like they used to. They didn't used to salt like this, okay? We have this magic product called Slice. It's magnesium, and it just eats up everything it touches. And I know it does that. So I've asked one personally. He's like, well, people want, dry roads the day after it snows. And I get it. It's a safety thing, but, it's like I go to Colorado, and I'm like, man, they don't seem to have to salt everything. People do, but I know it gets into the high aquifer. We don't see it in our drinking water aquifers, but I know it's in surface water. I went around with my daughter to do her science experiment, and we collected soil samples off the sides of the road. We did it in 3 different seasons, and then we got a multimeter. We put it in. We tested pure distilled water, no current. We put in a certain amount. We weighed it out, did the whole science thing. There was a current flowing through the salty dirt on the sides of roads. And Canyon Road's one of the worst. It was Canyon Road and East Road, yeah.
Thank you so much.
You bet.